Hi everyone and welcome to lesson 2 from topic 9. Today we are continuing with our um, lesson on transformations, and the one we are talking about today is called a reflection. So when you're working with something on a coordinate plane, you can reflect it somewhere else on the coordinate plane, and today we're going to be learning about how that works and what happens when we do that. So we're remembering our story from our previous lesson where the friend drew this shape and then we had to finish it. He slid it over. It was a translation. He slid this over. Um, Now he's reflecting it over this pencil. So this is the original and he's going to flip it over here. So it's saying finish drawing the triangle on the right hand side. So go ahead and try this in your book. And when we're reflecting something over, we could just see, okay, there's one space between the original triangle and the pencil. So there's one space on this side of the pencil and the new triangle. It's going down. So this is going to go down. It looks like the 90-degree angle has 2 units. So we're going to make this one also have 2 units. And then we're going to connect the lines. Oops, that's not a straight line, but hopefully you get the idea. So we have our reflected triangle on the other side of the pencil. So we're going to be learning about reflections today, and there's this 1-minute video that we're going to watch, and then we'll talk through some more examples together.
A reflection, or flip, is a rigid motion that flips a figure over a line called the line of reflection. If a point A is on the line of reflection, then its image A' is itself. If a point B is not on the line of reflection, then B and B' are on opposite sides of the line of reflection. They are on a line perpendicular to the line of reflection and are the same distance from the line of reflection. B and B' are the same distance, 3 units, from the line of reflection, the y-axis.
There's another funky dance called the reflection groove. It's a pretty cool trick, just a flip of a figure over a line. A rigid motion, a simple notion, you will use it all the time. Come on and move. Do the reflection groove.
Okay, sorry about that song. I know it's not the coolest song out there, but I wanted you to be able to see all those different examples of reflections as that square was moving around. So when we're working with reflections, we always have what's called a line of reflection. And sometimes it will be the y-axis, sometimes it'll be the x-axis, sometimes let me see if I can back up a little bit. Sometimes like this one, it will be the -1 axis. Sometimes it will be on an angle. So we're always going to be looking for our line of reflection. And then basically remember that when you have the original image, that's called the pre-image, and the new drawing, the one after we reflect or rotate or translate the object, is called the image, and we say like A prime or B prime as we label the points. Okay, so we have the pre-image and the image. And I know we talked about that last time, but just want to remind you so that when we use that terminology this lesson, it's fresh in your mind. So let's go to part 1 and do some work with this. So first of all, we're just going to be starting with identifying reflections. So which one actually is a reflection? And if you ever did this project as a kid, you might have done this. Now, this is going to be a very poor drawing, but maybe you did something where you had a piece of paper and you folded it down the middle like this, and you drew half of a butterfly. I don't know if you ever did this as a kid, but you drew half of a butterfly on this side and you gave it an antenna and you decorated it and you made it all pretty and you had this lovely butterfly. And then maybe you did this with paint, so everything is painted in here. Well, you folded it because then you can take this edge of the paper and fold it over and like make a sandwich and press this piece of paper down onto here. And when you open it back up, you're going to have the other half of the butterfly. And it will have the same designs as your other one. It's just going to be flipped a little bit because it's a reflection. And so this fold line, let me make it in a different color here. This fold line in green is the line of reflection because this half of the butterfly got reflected onto this half of the paper. All right, so when we're looking to identify transformations that are reflections, we are looking for and this is not mathematically correct, but do the butterfly wings match over the fold? So do, in this case, the triangles match over the fold? So if we were folding it, let's say over the Y line here, if we were to fold this blue triangle over, actually this black triangle over to the blue because these are the prime ones. If we were to fold the black one over, then we would, A looks like it would be in the same spot, but C and B are not in the correct places. And we can check that because we see if we're using Y as the reflection line, which it looks like they are, there's 1, 2, 3 spaces to get to C on this side of the line, and 1, 2 spaces to get to C on this side of the line. So it doesn't work because it needs to be the exact same distance apart because we folded it on that line essentially. So hopefully by looking at it, you can say, okay, it is the second option that is a reflection. So in your got it, it's asking you which one shows a reflection of triangle DEF across the x-axis. So now they're folding it on this line. And I keep saying folding it because I'm picturing that butterfly when I picture these problems. So picture if you were to fold this black triangle and fold it over, would it end up right here? Hopefully you said no. This one, they're tricking you. They're having you think it's on the y-axis, but it specifically says the x-axis, which is this one. So if you were to fold it over, that wouldn't work. How about this one? Here's the black triangle. If you were to fold it, well, we're allowed to kind of cross over onto our other side because this F point crossed over onto the other side of the X. So naturally it's going to cross over onto this side of the X when we have our reflection. So this third option is our correct choice. That one is the one that shows a reflection. Okay, for some reason part 2 is not opening up on my computer, so I'm just grabbing the example from the Got It book that you should have. And then we're gonna do this problem together instead of the computer problem. Okay, so in this Got It example, it says LMNP is a parallelogram. Describe in words how to map LMNP to its image L prime, M prime, N prime, P prime. So LMNP is this darker black parallelogram, and then the new parallelogram is the light gray one. So whenever I think about these, I'm asking myself, where could I have folded the line, or where could I have folded this graph so that it would perfectly match up to this point up here? And basically, I'm going to look, okay, so I'm going to first check this x-axis right here. And I'm going to check. So I want to make sure when I'm checking that each of the coordinates are equidistant, which means equal distances from the line of reflection. So remember that red line is called the red line of reflection. So I'm going to check point M right here. Point M is only one space away from this line of reflection, but this M is 1, 2, 3 spaces away from the line of reflection. So I know that the x-axis is not the line of reflection. So let's go ahead and count how many spaces apart M is from this M. It is 1, 2, 3, 4. So I'm going to hope that this line right here is going to be my line of reflection, because that way I have M being exactly 2 spaces away here and this M being exactly 2 spaces away here, and all of my other points should follow. So P prime is 2 spaces away from the line of reflection, and P is 2 spaces away from the line of reflection. That's great. N is a little bit farther. It's 1, 2, 3, 4, 5 spaces away. So we want this end to also be 5 spaces away. 1, 2, 3, 4, 5 spaces away. Okay, good. And we can check L too. There's 1 space and 1 space. So this red line, let me make it blue now because we know that's the right one. This blue line is our line of reflection. So which line is that? Basically, that is all of my coordinates are going to have, like this is the coordinate 1, -1, 2, -1, 3, -1. So I've got -1 as my y value, no matter what my x's equal. So the line is y equals -1. So if we were just to describe this mapping, and mapping, when they say mapping, just means how did they change, how did they get the original shape to be in the new shape? So how did they map it out? So we could say in words, it would be something like, I'll add this up here, parallelogram, LMNP, probably should use caps, is mapped to L prime, M prime, N prime, P prime through a reflection over the line y equals -1. So that would be a perfectly great explanation for how we got, this reflection. So now we have our last example for today. And again, this is going to be showing us how to actually do the reflection when we're working with an image or a pre-image, trying to find the image. So let's take a look at this one. It says the vertices of triangle ABC are these coordinates, 1, 3, -2, 4, and -1, 1. Graph triangle ABC. So first we have to graph, and then A prime, B prime, C prime, its image after a reflection across the x-axis. Okay, lots of information in there. So first we need to graph. So let's focus on just graphing, and then we'll go back to the rest of the details. Triangle ABC. So A is at 1, 3, right here. And when you do these, it's very important that you label your coordinates so that way you can keep track of them. B is -2, 4, so -2, +4. Here. This is B. And C is -1, 1. Awesome. So here's our triangle. And do the best you can with, when you're doing these, connecting them with straight lines. If you have a ruler, that's preferable. Okay, so here's our triangle. We graph triangle ABC, perfect. And its image, so we also need to graph A prime, B prime, C prime after a reflection across the x-axis. So that means we're folding their paper on this line right here. And we're going to fold this half on to this half. So what we need to do is count how many spaces A is away from the line of reflection. It's 1, 2, 3, so it needs to be 3 spaces away here. 1, 2, 3. So this is going to be A prime. And you need to label it with that prime tick mark. All right, this is C. C is only 1 space away, so it's going to be 1 space away here as well. This will be C prime. And then B is 1, 2, 3, 4 spaces away. 1, 2, 3, 4 spaces away. B will be right here. B prime. And then you just connect the lines, and now you have your reflection. So just counting how far away you are from that line of reflection and drawing your new shape. Go ahead and try your got it and then your close and check. Here's the answers to your got it and your close in check.